Hello Year 9, welcome to the feedback on the P1 matter quiz you did on frog. How frog works is when you set it as an exam, unfortunately a student cannot know which particular answers were correct and which particular answers were wrong. It's not just the students, even the teachers. We also cannot see individually which all questions a student got correct. That is why we decided to do a whole feedback on all the 15 questions you did in the quiz. You would be able to you would have an idea with what were the answers you had given. So from that, you will have to work your feedback out. So let's move on to the questions. So question 1. So you have a fluid compressed by pushing the plunger into the body of a sealed syringe. Which of the statements is true? So you have 4 statements. The first one says there is a net force. Yes, we do know that there is a net force because we are pushing it. There is no force, which is completely wrong. Now we have 3 and 4, which says the forces are parallel, one of them says, and the other one says that the forces are at 90 degrees. So whenever we are talking about applying a pressure by pushing something, the force always acts at 90 degrees to all points on the surface of the fluid. So keep that in mind. The force always acts at 90 degrees if you are applying or you're creating a pressure. Question number 2. Which factor influences whether an object floats or sinks? The options were mass, weight, density, and depth of water. By now, you definitely know that the factor that influences it is the density of the object. Question number 3. The atomic model has changed over time. Why did the model need to change over time? This is a very common or very popular exam question. It has been asked many times before. Why do we change a model? We generally change a model when we can't explain the things that is happening around us using that model. So based on that, our answer should be the old models could not explain the new evidence. So when we have a model with us, we can use that model only if it can explain everything. The old ones, the new evidence we have, it should be able to explain everything. Otherwise, we have to replace that model. So the older models could not explain new evidence. Next comes the 4th question. It was a very easy question. You have been given the equation there. You have been given all the data there. And they are asking you what is the heat energy supplied. You have these many options. So obviously, you would have used your calculator, your pen, paper, and worked it out. And when you work it out, this is what the answer you get, 800,000 joules. But all the 4 options given to us are in kilojoules. So how do you convert joules into kilojoules? Yes, you have to divide it by 1,000. And when you do that, your answer should be 800 kilojoules. Now let's move on to question 5. You have been given a diagram there. You have been shown a diagram, and then they are asking you to calculate the density of the object. The options are given to you. So when you think about density, the first thing that should be coming to your mind is the equation for density. And yes, now you have in your mind that density is mass divided by volume. So now you have to look for the means to find mass and volume. So if you look into the diagram, you can see the object there. So if you look at the first part of the diagram there, without the object in water, it tells you that the mass is 103. And then with the object in the water, you can see that the mass has increased to 135. So from that, you can easily calculate the mass. Then the second thing we need to know is volume. So there again, you can see the first one, if you look at the readings where the water stands there, you can see it is 60 milliliters. How do I know it is 60 milliliters? Because between 50 and 100, I can see 5 graduations. So, or 5 divisions. So 5 divisions is 50. So that tells me that 1 division is 10. So it is 1 division above 50, so that makes it 60. In the second one, it is 3 divisions above 50, that makes it 80. And then I can find the volume of the object, because that increase in the volume of water was not increase in the volume of water, I'm wrong by saying that. That increase in the height of the water was due to the object added into it. So that extra that came there was the volume of the object. So now you have the mass and the volume. Then it is an easy peasy work to find out the density, and you will get the final answer as 1.6 grams per centimeter cube. All clear? So we are moving on to question 6. You are inflating a bicycle tire. What happens to the pressure and volume of air inside the tire? So you are inflating it, you're putting more air particles into it. So there will be more collisions with the tire, and the pressure of the tire would increase. More particles are going in, so the volume will also increase. So the pressure and volume both increase. Next comes a very easy question. Question 7. Which are the units of density? And these are your options. So whenever you have to figure out the unit of a particular physical quantity, all you have to think about is their equation or their formula. So think about the formula for density. Density is equal to mass over volume. Then think about the units of the individual quantities that comes in the equation. So mass. Normally we measure mass in grams or kilograms. So all the options given here gives you grams and kilograms. Then think about the volume. What is the unit for volume? So it is either centimeter cube or meter cube. So if you then look at the answers given to you, the first and second one of the units mentioned there is in centimeter square. Even the last one, it is in centimeter square. Centimeter square cannot be the unit of volume. So it can't be the unit of density either. So the right answer should be grams per centimeter cube and kilogram per meter cube. The mass in grams, normally that is what we follow. If we take the mass in grams, we take the volume in centimeter cube, and the unit becomes grams per centimeter cube. If we take the mass in kilograms, and then we take the volume in meter cube, and then the unit becomes kilogram per meter cube. Question 8. So the diagram shows atoms in a substance, how they rearrange themselves during the change of state. So it clearly tells you that a change of state has happened. So they are asking you which change of state is being shown there. So if you look at the first diagram, you can see that the particles are spaced apart. There is no arrangement at all. So which particular state of matter has that characters? It is the gas. And then if you look, the particles are close together, but still they are not following a pattern. And that happens in the case of a liquid. So the answer is gas to liquid. Question 9. It looks a bit wordy, but actually it is not a difficult question. So what the student is trying to do is trying to find the density of a metal block. For that, they first measure the weight with a force meter. Then they measure the sides of the block with a rule, and then they are using that to calculate the volume of the block. Then what they do is they divide the weight by the volume to find the density. After all this, the question tells you that the student has made a mistake. So what is the mistake? So the first one says density is volume divided by the weight. Is it? Is that the mistake the student did? Instead of dividing volume by the weight, the student has divided weight by the volume. Is that the mistake? No. They should have measured the surface area, not the volume. No, definitely they should have measured the volume itself. The weight, they should have used the mass in the calculation, not the weight. Hang on. Isn't there something there? So the previous slide, we talked about density, and we said density is mass over volume. And now the student here has divided weight by the volume. Is mass and weight the same? No, it's not. Mass and weight is not the same at all. So you have to actually measure the mass and not the weight, and then the student should have divided the mass by the volume, not the weight. So that is your answer. Let's move on to question 10. You have a measured mass of gas kept in a cylinder and then it is slowly compressed. If the temperature does not change, what happens to the pressure of the gas? You have the diagram there, and then these are your options. So you have a fixed mass of gas which is kept in a cylinder and it is slowly compressed. So when we are saying it is compressed, which property is changing there? Yes, its volume is changing. What is happening to the volume? The volume is decreasing. The other key word in the question is when the temperature of the gas is kept constant. It does not change. So all these things should be ringing a bell. So where have you heard this? Which law is this talking about? Yes, it is Boyle's law, which tells us that if the temperature is kept constant and if the mass is constant, what is the relation between pressure and volume? They are inversely proportional to each other. So if one increases, the other decreases. Here they are saying it is slowly compressed, which means the volume decreases. So then according to Boyle's law, if the volume decreases, what should happen to the pressure? It should increase. So next question, you have been given two scenarios here. Both of them have two divers and two of them are in seawater and two of them are in fresh water. They are asking you which one experiences greater pressure. So when we think about a liquid and when we think about pressure, we have already studied an equation which connects them. Pressure is equal to depth times density times gravity. Gravity is going to be the same in both of them. It's not going to change. So basically it depends on the depth and density. Now if we look back into the question, it says seawater is more dense than fresh water. So that itself, if you look at the divers there, A and C are at the same height, same depth, but then A is in seawater, so obviously A should be experiencing more pressure than C. But then when you look at B and D, so we know more the depth, more the pressure they are going to experience. So then we have to choose actually between B and D. That is where the data given in the question becomes handy. Seawater is more dense than fresh water. So if you look at B, it has the same depth as D, but it is in seawater, so it is more dense, which means B will be experiencing more pressure. So moving on to question 12, you have an isotope which has an atomic number of 11 and a mass number of 24, and they're asking you the number of protons, neutrons and electrons in it. So when you see an atomic number, it tells you the number of protons as well as the number of electrons. So an atomic number of 11 means it should have 11 protons and 11 electrons. So when you look into the option, the only option that has the combination of both 11 protons and electrons is the third option. And then we need to confirm. So we need to make sure the number of neutrons is also the same. To find the number of neutrons, what do? Mass number minus atomic number. So 24 minus 11 should give you 13. So 11 protons, 13 neutrons and 11 electrons. The third option should be our answer. Moving on to question 13, you have a graph and the question tells you that this is how the temperature of a crystalline solid changes with time. It is being heated electrically at constant power, which means we are giving it the same amount of energy each second. Which of the following regions shows the latent heat being absorbed? So the thing about the latent heat is that when latent heat is being absorbed, you will not see any rise in temperature. So you need to look for those parts of the graph where the temperature is not increasing. So we have already discussed this in the class. Temperature never changes during a change of state, and latent heat is always associated with change of state. So from the graph, the two regions where the temperatures are not changing is, look at the graph, B and D. So your answer should be B and D. Question 14. it is asking us which of the following statements are true. Let's check one by one. Alpha particles used in the Rutherford experiment are positively charged particles. Yes, alpha particles are positively charged particles. So that should be most probably our answer, but let's look at the other options also. Dalton assumed that atoms were made of protons, neutrons and electrons. Did he? No. What Dalton said was the atoms were like solid spheres. So he never knew anything about protons, neutrons and electrons being present inside the atom. So that is wrong. The next one says in Rutherford's alpha scattering experiment, all the alpha particles passed through the gold foil. No, they did not. And that was what led to the amazing discoveries later on. Most of them passed through, but there was a really small amount that didn't. Either they got reflected or they deviated a bit. And the last one was J.J. Thomson discovered the charge and mass of an electron. No, he did discover electron, but he did not discover the charge and mass of the electron. So we go back to our first option, and that is the right answer. With that, we come to the last question in the quiz. A ship can float on water because its weight is. So you have the different options there. Greater than the weight of the water displaced. If its weight is greater than water displaced, what would happen? It's not going to float. So when will it float? We have studied about the condition where objects will float when its weight is same as the weight of the water displaced. That is a condition for floating. An object can float on a liquid when its weight is the same as the weight of the water displaced. So year 9s, with that we come to the end of this feedback PowerPoint. You need to club this feedback PowerPoint with the next steps assignment that is being given to you. Using this, check which are the questions you went wrong and use that, and then go to your next, make a note of that and then go to your next step sheet and see what are the things you need to do, which are the other questions you need to do to reinforce the concepts where you went wrong. Okay, I hope you found this feedback useful, and you'll be getting another one for P5 also. Okay then, bye-bye.